I can find mean absolute deviation. Mean absolute deviation is the average distance of the points from the mean. But what does this mean? Here's a picture of what it means. If you find the average of the points in the top dot plot, you would find that it lands at the number 5. If you look at the other points on the dot plot, you first have to find the distance they are away from that number 5. At the bottom, you can see this. The number 2 is 3 units away from 5. The number 1 is 4 units away from 5. If we added up all of these numbers and divided by the number of them we had, we would end up with the mean absolute deviation. In this case, it's 3.83 units away from 5. That would be the average distance from our mean. To find the mean absolute deviation, there are 4 steps we can follow. The first step is to find the mean of the data set. The second step is to find the deviation, or the difference, of each of these data items from that mean. The third step is to find the absolute value of each deviation, or each difference. The absolute value is just the distance it is from 0. So basically, it's the one that just makes everything positive. The last step is to find the mean of the deviations that you found in step 3. Here's an example. We're going to start off with a little bit of an easier example. First, we're going to do the first step. The first step is to find the mean of our data set. So we're going to do that by adding these numbers. 0 plus 0 plus 1 plus 2 plus 34 plus 29. If we add all of these up, we should get the number 64. Oops, 66. Then we have to divide by the number of numbers, because that's how we find the mean. So we're going to take 66 and we're going to divide it by 6, because that's the number of data items we had in our set. 66 divided by 6 will give us 11. That means that our mean is 11. For step 2, we have to find the distance of each of these points from 11. To do this, we can just subtract. 11 minus 0 equals 0, equals 11. I'm sorry, apparently I can't even subtract. Then we have to do that again. 11 minus 0 again, because we have 2 zeros, is going to be 11 again. Then we have 11 minus 1, which is going to equal 10. Then 11 minus 2, which is going to equal 9. 11 minus 34. Ugh, this is why we have to do the absolute deviation, but just for now, so you know, that is negative 23. Then we're going to have 11 minus 29, which is negative 18. Now we don't really like to have these negatives in there, which is why we go to step 3, which is where we find the absolute value of each of these deviations. So we would just have 11, and then another 11, a 10, a 9, then we're going to make that negative 23 just 23, because that's the distance it is from the mean. And then negative 18 will become 18. Finally, we're going to find the mean of these numbers. So now we're going to add them up. 11 plus 11 plus 10, plus 9, plus 23, plus 18. Should get 82. Now, since we're actually finding the mean of these numbers, we're going to take 82 and divide by the number of numbers we had. So we're going to divide it by 6. We're going to go ahead and turn it into a decimal number, since it's going to be a little bit easier for us to see what's going on. As we notice on this step, once we subtract again, we're going to end up with a repeating pattern. So it's 13.6 repeated, and that means that the mean absolute deviation is 13.6 repeated. That means the average distance of these points from our mean of 11 is about 13 points away. Let's go ahead and try another example just so you can get some more practice. Just to make it more complicated, we're going to throw in some decimals. Steps are still the same. The first thing we need to do is to add up all of our numbers to find our mean. One thing you need to remember when you're adding the digits is you need to make sure that all of your place values line up. So for the number 9, even though there wasn't a decimal, that's showing that we have 9 and 0/10. You need to make sure that they line up in all of your place values. In the first column, we're going to have 5. In the next column, we should have 2. We're going to have to carry a 2 to our next place value. And when we add that up, we should have 6. So it should be 62.5. Oh, unless I missed one in there. Okay, 62.5, but all we've done is added. We still have to divide by the number of numbers. So now we've got to divide by the 5 numbers that we have in our set. Remember, the decimal stays in the exact place it was in before when we're talking about division, as long as there's not any numbers in our divisor, any decimals in our divisor. So the mean is going to be 12.5. Our next step is to find the distance of each of these points from the mean. We're going to have to do a lot of subtracting. If we take 12.5 and we subtract 12.3, we're going to end up with 0.2. if we take 12.5 and subtract 15.4, we're going to end up with a really yucky negative number. This isn't something that we have learned how to do, which means that for your own work, you will not end up with numbers that end up negative, but it's not such a bad idea to see them. So this would be a negative 2.9. Since we're actually going to be taking the absolute value at the end anyway, we actually could go ahead and figure these by putting the larger number on top, because they're all going to end up being positive when we're done anyway. We're going to take 12.5 and subtract 9. We should end up with a 3.5. And then we're going to take 12.5 and subtract 3.3. Remember, you have to be really careful to line up your decimals when you're adding or subtracting decimal numbers. Should end up with a 9.2. And finally, if we took 12.5 and subtracted 22.5, we would end up with negative 10. For the third step, we are going to turn all of these into positive numbers. So we've got 0.2. That negative 2.9 is going to become just a positive 2.9. The 3.5 will stay 3.5. 9.2 is going to stay 9.2. And the negative 10 is going to become a positive 10. For step 4, we're going to find the mean of these deviations. So we're just going to add them up. We should get 25.8. Now we're not done yet because we still have to divide by the number of numbers in our data set. So we're going to take that 25.8 and we are going to divide it by 5. 5 goes into 25 5 times. We have to subtract the 25. We'd have nothing left over, but we've got to bring down that 8. And then we're going to divide again. 5 goes into 8 one time. We'd have 3 left over. I'm going to go ahead and drag down another 0 so we can bring us out one more decimal place. 5 goes into 30 6 times. We subtract that 30, we don't have any left to go anyway, so the answer is 5.16. That means that we are 5.16 average places away from our mean of 12.5. Just like with range, mean absolute variation is one way to show the spread of data. So in addition to range, we could also use the mean absolute deviation to show the spread of data. Hopefully, even though you might be a little overwhelmed, you feel like you can find the mean absolute deviation.